Every now and then a research paper comes along that just completely blows your mind. This is one of them. It asks a really wild question. What if we could just throw out everything we think we know about how computers work? The hardware, the software, all of it. It's an idea that could genuinely reshape our entire digital world.
So let's just start with a little thought experiment. I want you to imagine the computer or the phone that you're watching this on right now. Now imagine it has no processor, no memory chips, none of that fundamental hardware we've been relying on for decades.
And then, what if all of it, I mean, the computation, the memory, the user interface, the whole shebang, was just unified into a single artificial intelligence? An AI that isn't just running on the machine, but an AI that is the machine. Now, this might sound like science fiction, but it's not. This is the core idea being explored right now by researchers at Meta AI and KAUST. They're calling it a neural computer, and it's a concept that really moves us away from our classic hardware stack to something completely different. Okay, so what exactly is a neural computer? To really get what this all means, we kind of need to break down the official concept. Right, that official definition is a mouthful, but the key phrase here is single latent runtime state. The best way to think about this is kind of like a computer's dream state. It's this single fluid space where the operating system, the apps, and your working memory, they aren't separate things anymore. They're all just intertwined as part of one unified neural network. It's a total paradigm shift. And to really appreciate this, you have to understand what a huge architectural leap this represents. We're talking about going from a physical, modular stack of components to a single, learned state of being for a computer. So here's the difference, side by side. On the left, you've got your traditional computer. Separate, engineered pieces of hardware for compute, memory, and I/O, and it runs on explicit programs we write. But on the right, you have the neural computer. It's a unified neural latent stack that doesn't execute code in the same way. Instead, it learns how to function simply by watching, by observing user interactions. Well, that brings up a pretty massive question, doesn't it? How on earth do you teach an AI to be a computer? The researchers started with a couple of really fascinating prototypes to figure that out. So they began with two proof-of-concept models. One of them learned how to operate a classic text-based command line. The other learned how to navigate a graphical desktop, with a mouse and windows. And the really cool part is that both of these were actually built on top of advanced video models. The way it learns is just ingenious. The AI is trained by watching tons and tons of screen recordings of people using computers. It's literally learning the physics of a computer interface, like when a mouse clicks here, a menu appears there, by constantly trying to predict the very next pixel that should show up on the screen. I mean, this all sounds incredibly ambitious, right? So, did it actually work? Well, the results from these early experiments were genuinely surprising, and maybe not in the way you'd first expect. So, it turns out the models got pretty good at rendering a believable computer interface. It looked and felt right. But that leads us to the million-dollar question. Is it just a really fancy video generator? Or can it perform actual, logical, symbolic reasoning? Can it compute? To put it to the test, the researchers gave their command line model, this NCCLIGen, a simple arithmetic test. And the results were not great. To be honest, they were pretty terrible. The neural computer scored a measly 4% accuracy. It could perfectly mimic a calculator interface, but it couldn't actually do the math. Yeah, just let that sink in for a second. 4%. Now, on the surface, this looks like a complete failure, right? The model can draw a calculator, but it can't calculate. But then, the researchers tried something clever. They didn't change the model one bit. All they did was change the instructions they gave it, a technique called reprompting. They just made their prompts way more detailed, almost spelling out the steps for the AI. And with that one simple change, the accuracy shot up from that dismal 4% all the way to an incredible 83%. So what does this huge leap actually tell us? Well, it reveals something crucial. The neural computer didn't just suddenly learn how to do math. What it proved is that it's an exceptionally good instruction follower. It's more of a powerful renderer than a native reasoner. If you give it a detailed prompt that includes the answer, it will faithfully render that answer on the screen. This really shows that true symbolic computation, actual thinking, is still a massive hurdle for these kinds of models. This insight is super helpful because it helps map out the future for this technology. These early prototypes, they're just the beginning. The ultimate goal is something the researchers are calling a completely neural computer.
So what's the endgame here? A completely neural computer, or CNC. And for that to ever happen, it would need to hit 4 massive benchmarks. It has to be Turing complete, which is just a fancy way of saying it can solve any problem a normal computer can. It also needs to be universally programmable, behave consistently every time, and actually deliver on the promise of this new flexible architecture. It is a very, very high bar, and we are just at the very, very beginning of this journey.
And all of this leaves us with one final, fascinating question to chew on. For the entire history of computing, we have painstakingly engineered every single layer of our machines, from the silicon chip all the way up. This research points to a totally different path, a future where our computers aren't designed, but are grown and learned, almost like a biological brain.